1.1, and 1.2, and to my horrendous surprise, error. Okay, I don't know what have I even taught you all. Maybe you can ask me Steve, what does terrible actually mean? Okay, so let's look at question 4. Explain whether the line y equals to negative 6x minus 5 intersect the curve y equals mx squared plus 2 when m is less than 1. Okay, question wants us to explain, right? So to explain whether the curve intersect the line or not, we use the discriminant to provide as an evidence for explaining it. Okay, so with the line in y equals negative 6x minus 5 and the equation of the curve in y equals mx squared plus 2, to check whether there's any intersection or not, okay, we will equate the two equations, right, to see if there are any solutions or not. Because if there are solutions to this equation, that will mean that there are intersections. Okay? But by determining whether there are any solutions or not, we can just use discriminant to check whether there are or there aren't. Okay? We need not go and determine what exactly is the solution. Right? So to know what is the discriminant, we need to rearrange this equation. So perhaps, okay, we can have everything placed to the right. So that will be plus 6x plus 5 plus 2. Which simplifies to be mx squared plus 6x plus 7 equals to 0. Okay? So the discriminant itself will be b squared minus 4m 4ac. So a is m and then c is 7. And that will simplify to be 36 minus 28m. Okay? So, to check whether there are any intersections or not, we need to check whether is it going to be more than 0 or less than 0 or even equals to 0. Okay? So, how do we check that? We are given this information here. So, m is less than 1. That means that negative 28m will be more than negative 28. Because we multiply this inequality by negative 28 on both sides, that will swap the inequality sign, and then we plus 36 on both sides. Okay, and 36 minus 28, that will be giving us 8. Okay, which means that 36 minus 28m, which is the discriminant, is more than 8, in other words, more than 0 also. Okay, so we say that since the discriminant is surely more than 0, okay, we can say that there are solutions to this equation, which means that there are intersections, in fact, 2 intersection points, okay, between the line and the curve.
Thank you.
Intersection points. Okay, so that will be how we go about explaining question 4. Right? Questions? Yang Yi and Janelle, do you want to share your conversation with your partners? I can hear very loud. Okay. Yes. It's one line, one curve, not two lines. What is touch but don't pass through? Tangent. It's a tangent, is it? What do you think then? What does intersection mean? Ask, what does intersection mean? If a line passes through a curve like that, that means the line being the Is it called intersection? It is what? What is intersection? Intersection means meet at one point, meet at least at one point. You can't intersect something. So this is still intersection point. Okay? Just that in this case it is more than 0. So surely we know that there will be 2 intersection points. It cannot be 1 intersection point. I mean, if the question were to ask how many, okay, then we need to write down the 2 intersection points, right? Although the question this time around didn't ask for how many, you can just say that the line intersects the curve, that will be sufficient. Okay? Right, so that's for question 4. Any questions regarding question 4? Okay? Right, next we look at question 5C. Okay, question 5C, we want to find the range of, the values or range of values of P. Okay, such that in part C it is x squared plus p squared equals to 3px minus 5 has real and repeated roots. Okay, so real and repeated roots, what does that mean? How many roots are there? 1 or 2? There's actually 1 only, because repeated one. Okay, for any quadratic equation, we can have up to 2 solutions, but when it is repeated, it means that they are the same. That means there's only 1 solution only. Okay, so take note of this word. Okay, there's only 1 solution. And with only 1 solution, what does that tell us about discriminant?
Equals to 0.
Equals to 0. Okay. So we will apply this given information to determine the range or the value of P. Okay. So given this equation here, we place everything to the left. In fact, you may want to arrange it in order to see very clearly what is your A, what is your B, and what is your C. Okay? So there are coefficients of x squared, x, and the constant term respectively. So your discriminant in this case will be 3p squared minus 4, 1p squared plus 5. Oh, minus, thank you. Okay, so that will give us 9p squared minus 4p squared minus 20, which results in 5p squared minus 20. Okay, so because the question has told us that there are real and repeated roots already, that means your discriminant will be equals to 0, hence we can solve it. Okay, whereby p squared is equals to 4 and hence p is equals to plus minus 2. Okay, because you take square root of 4, okay, positive and negative, so therefore it will be plus minus 2 itself. Questions? Okay. In comparison, we look at question 5D. It says that there are real and unequal roots. So unequal roots, what does that mean? They are not equal. That means that it is distinct roots. Okay, they are 2 different roots. So therefore, your discriminant will have to be more than 0. Okay. So 5B. Okay, so we do the same to determine what is the discriminant.
So what's unequal?
What does unequal mean to you?
Yeah.
What does it mean? What does unequal mean? In English,
Not equal.
not equal, right? So there are two solutions, they are not equal, that means they are different. So that means the discriminant is more than 0. Okay, so 8p minus 7 more than 0. So we find that the range of values of p will be more than 7 over 8. Sylvie, would you like to join it outside? Okay, questions? Alright. Next, we look at question 7. Okay, so in question 7, we want to find the range of values of p such that the curve and the line intersect at two distinct points. So to intersect at two distinct points, what does it tell us about discriminant, Fari? What does two distinct points mean about discriminant? More than 0. Okay, so what we will have to do is to take the curve and equate it with the line that we have. Just that the line that we're given is y plus 2x equals to p, so we just do a substitution. This is y equals to 2x squared plus x plus 2p minus 1. We place the y over here, so we get this new equation here. Okay, and then we simplify it to arrive at this. Okay, and simplify up to this, so that we can recognize what is the A, the B, as well as the C. Right? Then we can determine what is the discriminant, so that we can apply it to say that it is more than 0 due to it having two distinct points. Okay, so the discriminant comes out to become 7 Okay, for question 14, yeah. Huh? No. Okay, so question 14, you're given this equation to model after cost in thousands of dollars. Okay, then N is in 100 pairs of running shoes. Okay, we must take note of the units that are being used, how it is being defined, because C is actually in thousands of dollars. So for example, if you let C to be 10, that means your cost of production is $10,000. If you let C to be equals to 5, that means your cost of production is $5,000. Okay, so the C value and the total cost of production is two separate things. So it depends on how it is being defined. Then N is in terms of hundreds, okay, pairs of running shoes. Alright, so in part I, we want to explain why it is impossible. Okay, impossible for the cost of production to be $10,000. Right, that means that if I have 10 being placed inside here for my value of C, I'm unable to solve this equation. That is what the question is trying to say. That when C is equals to 10, okay, there will be no value of N that is possible. Right? You can never have that number of pairs of running shoes. So, to explain why it is impossible, we use discriminant to go about explaining it. We have the idea that it is not possible to solve. That means that our discriminant will have to be less than 0. Okay? So, in part I, when C is equals to 10, quadratic equation such that we need to determine the discriminant. Okay, so that will be negative 14.4 squared minus away 4 times 1.2 times 43.7. Okay, don't recall what is the value. Comes out to be about negative 2.4. So this is less than 0. So it fits the question. Okay, because the question is asking you to explain why it is impossible. So surely you should expect that the discriminant is less than 0. So to explain it, we say that since the discriminant is less than 0, okay, so all this forms part of your explanation. We just have to end off with the conclusion that the discriminant is less than 0. Okay, then therefore, it is impossible to have a cost of production of $10,000. Right? So that will be how we explain it. Okay, I got very frustrated when I was marking your homework. Okay, because you are so obsessed about trying to keep everything short, giving me the most minimal amount of working. Okay, such that you lose the whole idea about what you're supposed to be doing. Okay, so I don't want us to be so obsessed and so hung up about trying to reduce the number of steps, not doing this, not doing that, and all that. Okay. I don't understand why you want to compromise your own learning in that manner. Okay? We always want to give the most to get the best results, right? That you're most deserving of. Okay? You don't try to shortchange yourself. Okay? When you're not even certain whether that is going to be correct or not. Okay? So please give me a full set of working as for how I actually present it in class. Right? Then in part 2, to explain why it is possible, so we apply the same concept. Instead of C equals to 10, C is equals to 80. Okay? And then after that, you do the same sequence of things. So discriminant, go and calculate it. You should expect your discriminant to be more than 0. Okay? Because it is possible. Alright, so I'll leave it to you to do part 2. Okay? Because I know that the problem comes in for part 3 instead. values of x. So that one is clear. That's what we want to find. Okay? What the context is given to you is that the cost of production is always more than x thousand dollars. Okay? So this is the condition given to us here as well. Yeah? So the context given to you, the conditions given to you is this. Okay, which means that the cost of production, which is the given equation over there, okay, is always more than, so we are expecting this inequality sign, x thousand dollars. Okay, we put x only, we don't need to put $1,000 because this entire expression is your C, which is already in thousands of dollars. Okay, so they are equivalent, okay, in terms of the quantity itself, in terms of the measure. So this is our understanding. Okay, now x is a number, it is not a variable. Okay, it is just a number that you do not know what is it actually going to be. So we're expecting the cost of production to be more than x. In other words, we can also understand it as this entire quadratic expression being more than 0. Okay? So when we say that a quadratic expression is always more than 0, when does that actually happen? Okay? It is a situation where you have a U-shaped curve always above the x-axis. This is what it means, right? Which means that there are no intersection points with the horizontal axis. In this particular case, n is the variable, x is a constant. Okay, we must be able to distinguish between variable and constant. Okay, because your n itself is the number of running shoes. Okay, it can change depending on how many pairs of running shoes there are. Your cost of production is different. Okay, so that is the variable. X itself is just a number that we're trying to do comparison with. Okay, just that they give you an unknown. So x is no different from your part I and part 2, whereby x is 10 in this case, and then in part 2 x is 80. That is what the question is trying to draw reference, trying to distinguish itself from part I and part 2. So with that understanding, we are expecting that the discriminant to be less than 0 and the coefficient of n squared, okay, in this case must be positive, which we can also clearly see that it is positive already. And coefficient of n squared must be more than 0. Okay, these two things must happen in order for us to get this shape. Okay, we cannot be having a set face curve that is always above the x-axis because we already established the understanding that I can extend, okay, my curved lines such that there is intersection. So this is never possible. Okay, to arrive at something that is always more than 0. Yes. Because I said already, this means that your quadratic curve more than 0 always above x-axis. All your y values, this comes out to become the y value, being always positive, that means that it's always here one. Any point must be above. Yeah, you cannot have one point that's below one. Then it doesn't satisfy the inequality of more than 0. Okay? So that's why discriminant must be less than 0. Because your curve does not intersect the x-axis. Does not intersect means discriminant less than 0. So you cannot draw the link between this and this, think that they are the same. They are different meaning. Yes. Okay, right? So discriminant less than 0. Okay, we need to find out what is the discriminant. Okay, so the discriminant in this case, your A is actually 1.2. B is negative 14.4, your C is 53.7 minus x. Okay, so discriminant is negative 14.4 squared minus away 4 times 1.2 times 53.7 minus x. Okay, then we compute this out. This is our 7.36. Plus 7.76 plus 4.8x. Okay, so we have a simplified discriminant to be negative 50.4 plus 4.8x. Okay, then because the discriminant must be less than 0, we form this inequality. Okay, such that we get 10.5. Okay, so we know that at this juncture that your x can go only up to 10.5, not inclusive, because x must be less than 10.5. But what exactly is x? X is referred to be the thousands of dollars. It is the cost of production. So it is a money quantity. Okay, so for money quantity, the lowest it can go to will be 0. So therefore, okay, the complete inequality must be between 0 to 10.5. Because the cost of production cannot be going below 0. Right? So that's why that's the answer. Okay? Question.